Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with our binary search playlist, which is the part of the Strivers A to Z DSA course. In case you haven't checked it out here, there's a link in the description. Please do make sure that you check it out. So the problem that we are going to solve today will be finding out the minimum number of days to make m number of bouquets. Now what does the problem state? You'll be given an array bloom day, which will be consisting of the blooming days for n flowers. What does it mean? So the 0th flower, like the 0th index flower, will be blooming on the 7th day. Before that, it hasn't bloomed. This particular flower will be blooming on the 13th day. This flower will be blooming on the 12th day. Now your task is to tell me what is the minimum number of days you require such that you have ample amount of blooming flowers to make m bouquets, 2 bouquets in this case, and you should have taken 3 adjacent flowers to have 1 bouquet. Let's understand the problem statement in depth. Now imagine all the flowers are bloomed. All the flowers are bloomed, and that will only be possible if you are on the 13th day. If you are on the 13th day, this would have already bloomed on the 7th. This one will be blooming on the 13th. This would have already. So all of these flowers will be bloomed on the 13th day. What do you need to make? You need to make 2 bouquets of 3 flowers. So you have to take 3 flowers, that will make 1. And you have to again take 3 flowers, that will make another bouquet. So you have to make 2 bouquets. Okay. So what I can do is, I can probably take these 3 adjacent flowers and I can have 1 bouquet. Or maybe I can take this 3 adjacent flowers and I can have 1 bouquet. You can take this as well. You can take this as well. Doesn't matter. As long as you're taking 3 adjacent flowers and you're making 1 bouquet, that is what matters. So I have formed 2 bouquets. So I can say that if I take the 13th day, if I take the 13th day, I'll be able to make 2 bouquets by picking up 3 adjacent flowers each. So thereby 13th day is a possible answer. But the question states you to find out what is the minimum possible day. So what if I would have taken 7th day. Let's take this. 7th day, if I take, this would have bloomed. This would have, this would have, this would not have, this would not have, this would not have, and this would have. So I would have been able to make 1 bouquet over here, and I cannot make any other bouquet. Why? Because they are not adjacent. They are not adjacent. So I cannot make any further bouquets. It's very critical that 3 of them should be adjacent. Okay. So this is not possible. Can I do it on the 12th day? Let's see. If I take the 12th day and I say, okay, this will be bloomed, not bloomed, bloom. Why? Because this needs 13th day to bloom. Can I make 2 bouquets? Let's see. I can take this as 1 and I can take this as 1. So I can actually make 2 bouquets if I'm taking the 12th day. Can I get anything better than this? Let's try it. Let's take 11th. So if I take 11th, bloomed, this one will be bloomed, this one will not be bloomed, this one will not be bloomed, sorry, this one will be bloomed actually, and this one will not be, and this one will be. Can I make 2 bouquets? Let's see. 1 I can surely make. Can I make another one? No. I have 3 separate flowers, but the point over here is you need adjacent 3 different flowers, so not possible. So apparently it is not possible to make on the 11th day. And if you carefully observe, 12th was possible, 13th was possible, 11th is not possible. So if 11th is not possible, 10th will not be possible, 9th will not be possible, 8th will not be possible. Anything under 11 will not be possible. So can I say from 1 to 11, nothing is possible. 12 and 13, both are possible. And what do we need? The minimum number of days. So thereby, can I say, if I wait for 12 days, I'll be able to manage these amount of bouquets, right? So 12 is the answer for this one. Let's take one more example. What about this? Now in this, they're asking you to make 3 bouquets with 2 flowers each, But if you carefully observe, even if you take the 10th day, all the flowers would have already bloomed and I can at max make two bouquets. That is what I can make. And the problem is demanding you to make 3 bouquets. So in such cases, you have to return me -1. And that is the problem. If it is possible, tell me the minimum number of days. If it is not possible, straight away return -1. That is what the question states. So how do you approach this problem? Always remember, whenever you are solving a problem, the first approach should be, how can I solve this in some way? And then we can think of optimizations. So the first thing that I should think of is, how do I deal with the impossible case where I have to return something as -1? So we know one thing for sure. If we take the maximum bloom day in the array, which is 10, all the flowers would have bloomed, right? And in such case, the total number of flowers will be n, which over here is 5. They want 3 bouquets of 2 flowers each, which is a total of 6. So can I say, if at any moment m into k, or whatever is the number of bouquets into the number of adjacent, exceeds the n, this is not possible, and this is the case of -1, because I have already bloomed all the flowers and I can always pick up adjacent. Because all the flowers will be picked. And if I cannot make this total, and hence that's greater than n, then I just straight away return -1. So this is the only impossible case. Apart from it, all the cases are possible because it is possible to bloom all the flowers. So you'll be able to pick up adjacents for any given thing which is lesser than equal to n. Thereby it is possible. So we have figured out the impossible case. Now let's come back and try to solve the case where it is possible. If I ask you a very simple question, what is the maximum answer? Like, what's the short answer? Can I say, if I look at the array and if I take the day 13, everything will be bloomed. I can surely say that if I take the day 13, everything will be bloomed. And if everything is bloomed, I need 2 bouquets. I'll just pick up the first 3 adjacents, and that is possible. So one thing I know for sure is 13, like whatever is the maximum value in the array, that is for sure going to be my, like, that's definitely going to be one of my answers. But the problem is I need the minimum. So I need to figure out a smaller value than that maximum possible answer. The question is, what is the minimum possible answer? Now you can probably say 1 day and check it out. And then you can say 2, check it out. You can say 3, check it out. You can say 4, check it out. But ideally, what can you do? You'll be like, maybe take the minimal possibility, because in order to bloom at least 1 flower, you need the day 7. Then only you'll bloom something. If you take day 6, nothing will be bloomed and you cannot even form 1 bouquet. So in order to at least bloom 1 flower, you need the minimum day, which is 7. So I know one thing for sure, that my answer will always lie between 7 and 13. Again, very, very easy thing to observe. You just need to observe these things. Remember, in order to approach these kind of questions, the first thing is figuring out the range. Again, you can even take this as 1 and you can take this as some big integer as well. That will also work. But the goal is to minimize the range as much as possible. So what I've done is I've taken 7 and 13. For this one, I know that from 7 and 13, like between 7 and 13, there will be someone who will be my answer. So what I will do now is, I'll take the day 7 and I'll try to see which flowers have bloomed. Bloomed, not, and bloom. Now what I'll do is, I'll start iterating. Once I know what has bloomed and what has not, I'll start iterating. I'll be like, okay, counter 1, counter 2, counter 3, counter 4, and the moment I reach here, I see it hasn't bloomed. Thereby the counter is 4. How many, like before turning this, because you've got an unbloomed flower, so the counter will go back to 0. So as of now, you have a consecutive 4 bloomed flowers. If I ask you, how many bouquets can you form? You need 3 adjacent. Can I say the number of bouquets that you will form out of 4 consecutive will be 1? So you just have 1 as of now. So you trim down the counter to 0 and then you move, and then you move and the counter is 1 again. So at the end of the day, the counter is 1. Remember, at the end of the day, the counter is 1. So when you have ended everything, again you check. You have 1. How many bouquets can you form? 0. So what is the overall number of bouquets that you could form? 1. And how much did you require? 2. So this day is not possible. That is how you figure out. Okay, perfect. So day 7 is not possible. What you do is, you take day 8 and again you do the same thing and you will see that you can only form 1 bouquet. Next, you'll take day 9 and again you will see the same pattern. Next, you'll again take day 10 and again you'll see the same pattern. Next, you'll take day 11. And the moment you take day 11, let's try it out and see. So, yes, yes, yes. And this will be no, this will be yes, this will be no, and this will be yes. Let's again try to do the same thing. Counter equal to 1 when you are here, goes ahead, counter 2, goes ahead, counter 3, goes ahead, counter 4, goes ahead, and it finds a non-bloomed flower. So he has a counter 4. How many bouquets will he get? 1. Perfect. Counter turns down to 0, again starts from 1, again goes to somewhere which is not bloomed. So how many bouquets will he make? 0, turns to 0, again goes, which makes the counter 1, and it ends at the end of the day. Whatever is the value, you again check it and you get 0. So the total number of bouquets that you can form is 1. So day 11 is also not possible. Okay, we have understood this. What's the next job? Take day 12. If you're taking day 12, let's again do the same thing. Possible, 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 not possible, 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 possible. Let's do the same thing again. Counter equal to 1 when it is here. Moves ahead, counter becomes 2. Moves ahead, counter becomes 3. Moves ahead, counter becomes 4. Moves to an unbloomed flower. Moves to an unbloomed flower. So again you go back to counting the number of bouquets that you can form from that consecutive numbers. That's 1. The moment you come to unbloomed, you make it 0. And then you move back. Counter becomes 1. Counter becomes 2. Counter becomes 3. And it is over. At the end of the day, I emphasize, at the end of the day, it is very, very important to whatever you have, you just do a 3 by 3 and say 1. So the total number is 2, which is the required bouquets. So you started from 7. If you remember, the range was 7. You went 8, 9, 10, 11, and then you are at 12. At 12, you see that you're able to form 2 bouquets, thereby possible. Hence, your answer is 12. You can try with 13 as well. But the question states to find the minimum number of days. Got it? So first, I'll try to write the function which kind of takes the day number and tells me if it is possible or not. Okay. So let's try to write down that function and then we can go ahead and probably write down the normal brute force thing. Let's first try to write down the function which tells me possible or not. So I'm basically taking this array which has all the bloom days and I'm passing him a very simple value. So what is this value? Or I can say the day. Or I can say day. Okay, I'll say day. And this is where I start writing the code. So what I'm saying is, okay, if I'm giving you this day and I'm also giving you maybe let's say what is there? M and K. So these are the number of bouquets I need and this is the adjacent that you can have. Perfect. Let's start writing code. So let's take initially the counter to be 0. And let's start from int I equal to 0 and I can go on till n minus 1, which is basically the size of the array. I know one thing. If array of I is lesser than the bloom day, like whatever day you are considering, if you're considering 8th, if you're considering 9th, that means the blooming is possible. That means the blooming is possible. If it is possible, you simply do a counter plus plus. You do not do anything. You simply do a counter plus plus. If it is not possible, that means you are in an unbloomy, like you are in this phase where it is not possible, when you turn it to 0. But before turning it to 0, what did you do? You took whatever it was and you divided it by this. So maybe what you can do is like number of bouquets that you can form will be 0. You can say number of bouquets that I can form will be plus equal to whatever consecutive I had divided by the adjacents that I require. That is what we did, 4 by 3. And you basically take that and you add it into your number of bouquets. And you turn back the count to 0 because you again start counting consecutive. And that's over. Again, I emphasize at the end of the day, please make sure whatever you have the count as, you again divide it by k, because remember the case when you had this, at the end of the day you had 3, you have to make sure you count it as well. So at the end of the day, please make sure you count it. Is it possible? If number of bouquets is is greater than equal to the required, it is possible, or else it is not possible. So I've written down the function which takes a array which is the bloom day, takes the day that I'm looking for, takes the number of bouquets required, and takes the adjacent and tells me if it is possible or not. So this is ready. This is ready. I'm trying out with a brute force. So I know what will be my range. So I'll start off with what? The minimum possible element, and the maximum is where the answer will be. So I'll just go over there. What will I say? If possible, give him the array, give him this day, give him the m, give him the k. If this is possible, then return this answer, then return this answer, or else you can just go ahead and increase the value of I and check for the next day. So this is going to be the brute force solution. And if we have tried out everything and at the end of the day you don't get your answer, you can return -1. Again, at the start you could have straight away checked if n, if n is lesser than m into k, then also you can return a -1, because that is the impossible case when you exceed. So I've written the brute force. What is the time complexity? It's very important to understand the brute force, because the moment you understand the brute force, it's super simple to optimize it. What is the time complexity? This loop, can I say, is running for maxi minus mini times, because that is what it is running for. Maxi minus mini times. Perfect. +1 actually. If I take the exact number, it will be +1. Yeah, these many times it is running. Into, you're checking for a possibility. You are checking for a possibility. And in order to check, what are you doing? You're going through the entire array. So it's a big O of n. It's a big O of n. That will be my time complexity. Yes, that will be the time complexity of the brute force. Now the question arises, can I optimize this? Can I? Probably I can. Why can I? Let's go back in order to write this. We had 7, 8, because that was the range in which the answer was possible. We had the range something like this. And we knew this was not possible, this was not possible, this was not possible, this was not possible, this was possible, and this was possible. So we know the range, and we know in which area it is not possible, in which area it is possible. So if I know this, the problem becomes super simple, isn't it? Yes, binary search. We straight away apply binary search by saying this is my low, this is my high. I know where it is possible, where it is not possible. I straight away apply binary search. So you can pause the video right away and you can try out the binary search solution. In case you're having problems or in case you want to verify, you can come back and watch it from here again by doing a fast forward. Okay, so time for binary search. What's the first component in binary search? To figure out the range, we have already done that. We know the answer will be from 7 to 13. That's the minimum element and that's the maximum element. What we do is we keep the low at this and we keep the high at this. And I'll quickly write down the numbers so that we can start with the binary search. Where will the middle be? The middle will be 13 plus 7 by 2, which is 10 to start off with. So the middle will be at 10. So what you do is you take the 10th day and see if it is possible or not. So if you remember, on the 10th day, it was not possible. So what you can say is, hey, on the 10th day, it is not possible. So if it is not possible on the 10th day, can I surely say one thing, that if on the 10th day it is not possible, on the 9th it will not be, because lesser number of flowers will bloom on 9th, lesser on 8th and lesser on 7th. So what I can say is, none of the days before 10 will also be possible. Thereby, I can take this, yes, I can take this and I can move it to this portion. So we have a new range where we can find the answer. What will we do? We will take a mid. Again, the mid will this time be 12. I can't explain how to find mid now. Is 12 possible? You say 12 is possible. Maybe you can keep an answer variable as we did just so that in case you are facing problem with low and high, and you can store answer as 12. So what are you saying? 12 is possible. So I'm saying, okay, 12 is possible. What do I require? I require minimum number of days. If I require minimum, will I go ahead and check for 13 because I need small. Hence, I'll say if 12 is possible, eliminate the right, look for small, and thereby move the high to a point before mid, because you eliminate the right part. Binary search is all about eliminating ranges. Done. Where's the mid pointing? The mid is pointing to 11. What do we see? 11. Is it possible? You can again do the algorithm and you will see that 11 is not possible. If 11 is not possible, anything before 11 will not be possible. The left part will be eliminated. And if the left part is eliminated, what will go to the right? Yes, the low will go to the right because the left part is eliminated. So thereby at the end, when you eliminate left, the high will be pointing here and the low will be pointing there. We're done and dusted. Again, carefully observe. Where is your answer? Your answer is somewhere on the low. Your answer is somewhere pointing to... let's analyze. Do we need the answer variable? We don't. Why? Because the answer is already pointed by low. Why did that happen? Again, opposite polarity. I told you that concept. If you have a low here, which is assuming not possible. You have a high, which is assuming possible, assuming again. Low will end up at a point where it is of the opposite polarity, right? And the high will end up at the opposite polarity. Perfect. You see, high coming from a possible to not possible, low going from a not possible to a possible. Simple as that. So once you have done this, thereby the low will be answer because you're looking for possible. Got it? So that thereby the answer will be at low. So if I have to write the binary search, how will the binary search code look like? Remember, we have already written the possible code. So we just need to write the binary search. Can I say the binary search will be taking the array and the M and the K? What's the first job? Low will be the minimum element in the array. We can write a function to find it out. High will be the maximum element in the array. Again, you can write a function to find it out. And you can straight away go from... oh, my bad. Why am I writing the linear search? You can straight away start the normal binary search. That's from low to high. If you want, you can keep an answer just in case you want. And you're sure that the answer will be at high. And yeah, do not forget to implement the impossible case, which is if n is lesser than m into k, which is impossible, return -1. That's the impossible case that you can write. And over here, you can start the binary search with low plus high by 2, right? And then you can be like, hey, listen, is it possible? Is it possible with this particular array, with this day number, with m and k adjacent? If it is possible, this is possible. This can be my answer. And I need minimum. So I will eliminate the right half. So eliminate the right half. Or else, if it is not possible, it's too small a number. Increase. And you go ahead and increase. At the end, you can straight away return, what will you return? Low. Or answer. Whatever you feel like, you can play with answer, like you can just take answer, or you can also figure out low or high, which will be your answer. And in this case, low is, so you can straight away return this. What is the time complexity? So something is for sure the n, and this is for the possibility check. This is for the possibility check that you're doing. You cannot eliminate that. So n is for sure there. Multiplied with what? You're doing a binary search, and binary search takes logarithmic of the search space. What is the space? From 7 to 13 or from min to max? So it's like the space length is max minus min plus 1. That is the space length. Thereby the logarithmic base 2. This will be the time complexity. Am I using any extra space? No, I'm not using, because we're just making sure it is possible or not by checking with the day. We're not converting it into a possible or not. We're just simply checking and wait. So no extra space required. Thereby the overall time complexity will be this, and the space complexity will be a bouquet of 1. So let's quickly go back to the code editor. By the way, you can find out the problem link in the description, and you'll get the C++, Java, Python and JavaScript codes in the notes below as well. You can check it out from there in case you code in some different language. So I've written the same code, and instead of writing if else, I've just straight away written this. And something that you have to be careful about is this one. Because you're multiplying two integers, it might overflow. So first convert this into a long, and then multiply both so that they do not overflow. And apart from that, yeah, I figured out the minimum and maximum, and we did a simple binary search. So if you're watching till here, I hope you've understood everything. And in case you've understood everything, please do consider giving us a like. And if you're new to our channel, what are you waiting for? I think you should definitely subscribe to us. And if you haven't followed me on Instagram, LinkedIn and Twitter, all the profile links will be in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.